the sum of forces in the x direction equals ma of x. In an inclined plane, it can have both the force acting on it minus Fr. Now this is not the total net force acting on the object in an inclined plane because you have the y dimension, but we're going to focus on the x direction. So you're going to be deriving some of the x direction. Now F minus Fr equals m multiplied by acceleration. Acceleration is the derivative velocity with respect for time. So if we put this dt here, we can rewrite this as F minus Fr dt equals m dv. And since we derived, we can go back to integrate. So 0 to t F minus Fr equals the integral from 0 to v m dv. And so F dot t minus Fr dot t equals mv. Now ft can be written as impulse, but you're going to see now why I won't write it as impulse. Minus Fr dot t equals to m. Now velocity is the derivative of position with respect for time, and so F dot t minus Fr dot t dt equals m dx. Now since we derived again, what do? We integrate from 0 to t, and here from 0 to x. Now obviously we're going to keep assuming that v initial is 0 to simplify. Basically you can rewrite this as half ft squared minus half frt squared equals m of x, or mx actually, and this can be written as ft squared minus frt squared equals to mx. Now we know friction is not a restoring force, it cannot be conserved. Just a quick fact. Now we can factor out the t squared, so t squared f minus fr equals 2 mx, and so we can rewrite this as t squared equals mx, or 2mx, over f minus fr. T itself would be the square root 2mx over f minus fr. These are quick derivatives you guys need to know. So you guys need to know how to derive. The other equation I'm going to be deriving is kv minus mg equals f net. This is in a free fall, so this is when the drag force is greater than the weight. So let's get to it. So k multiplied by v minus mg equals ma. Now you guys can do this in both ways. You can make v the derivative position with respect for time and a the derivative velocity with respect for time. However, we can, this is what I like to do, make this velocity, because in velocity you can do many things, and since we're going to have both velocities in both sections, so kv minus mg dt equals mdv. And just like in the previous derivations, we would integrate since we derived. So from 0 to t, and here from 0 to v. And so we can rewrite this as k dot v dot t minus mgt equals mv. Now you can change this into momentum, so you can rewrite this as p, and you can change this into position, you can write this as vt. So this can be written as x, this can be written as momentum. This whole thing can be written as momentum. So, but I will not do that right now. We'll keep it the same. You're going to see why, because there is going to be another derivative. Minus mgt equals m dx over dt. So you guys can literally make anything, any derivative. And during your exams, if you guys are watching this for exams, or during any problem solvings, you guys can do anything you guys want, makes you feel comfortable. And deriving equations is probably best if you're going to go into college, or if you already are in college. This video shows you how to derive. It's the easiest derivations you guys can get. So we can rewrite this as the integral, since we derived again, from 0 to t k dot v dot t minus mgt dt equals the integral from 0 to x m dx. This can be written as half k dot v dot t squared minus half mgt squared equals m of x. Now k dot v dot t squared minus mgt squared equals 2mx. So now we can factor out t squared, or we can do it quickly. T squared equals 2mx, or actually kvt squared equals 2mx plus mgt squared. And so t squared equals 2mx plus mgt squared over kv. And you guys can do this both ways. Both ways works. If you factored out, then made the denominator also works. So t equals the square root of 2mx plus mgt squared, 2mx plus mgt squared over kv, and this would be your time. Now for mg minus kv, so when the weight is greater than it, this will be a bit more complicated, so we can rewrite this as mg minus kv equals ma, and so mg minus kv equals m dv over dt. It's best to have two variables at the same. So a variable here would be v, variable here would be v. Now mg minus kv dot dt equals m dv. Integrate both sides. I don't even need to say why, you guys know, which is because we derived. M dv integral, of course, we can be left here with mg minus kv dot t equals m v. Now this is getting too repetitive, so what I can do here is remove this and make dt equals mdv over mg minus kv. I mistakenly erased this. This is mg minus kv, and so we can integrate right now. And this here, we can use multiple stuff. Let's use, this would be t equals, now for this we're going to use u substitution, so u equals mg minus kv du over dv, of course, equals negative k dv, and then du over negative k equals dv. So it will be t equals the integral from 0 to v m over u du over negative k, and so t equals m over negative k, the integral of 1 over u du, which is going to equal to m over negative k multiplied by ln u plus c. Obviously no plus c, sorry. This is a finite integral. So t, or negative kt over m, equals ln u, which is ln mg minus kv. Now obviously from 0 to v, which is going to leave us with ln mg minus kv minus ln mg. So negative kt over m, this is a k, equals ln mg minus kv over mg, because ln x minus ln y equals ln x over y. And so to get rid of the ln, we can rewrite this as e to the negative kt over m equals mg over mg minus kv over mg. And so right now we can rewrite this as e to the negative kt over m equal to 1 minus kv over mg. And so, sorry, it's not, yeah, which can be written as e to the negative kt over m plus kv over mg, right? Yep, plus kv over mg equal to 1. Multiply mg in both sides will become mg e to the negative kt over m plus kv equals mg. And if you take this here, you can see now what we're going to do. Mg to the e, or e to the negative kt over m, equals mg minus kv. which is F net from the start. So we circled until we get an exponent. So get rid of this is F net, where F net is the same as MA. So mg e to the negative kt over m equals MA. And so you can cancel these two out. So we're going to be left with g to the e negative kt over m equals A. And so e to the negative kt over m equals 1. We cancel this because this is in the y dimension, and we know gravity is the only force acting, or the only acceleration acting in the y direction, because mg is greater than kv, and we know that mg, or the A of mg, is going to be the gravity. So we can rewrite this as e to the negative kt over m minus 1 equals 0, and 1 over e to the kt over m minus 1 equals 0. So we reached a definite answer. Now, what about the equation of f minus fr equals ma, using the same logic, minus mu n equals ma, which is the same as f minus mu mg cosine beta. I like saying beta. Ma, I don't like theta much. Let's use beta. We name our angles beta. Equals ma f minus mu mg cosine beta equals m dv over dt. And so we can rewrite this as f minus mu mg cosine beta equals m dv. Obviously here is dt, and so we can integrate. So that will be, okay, let's integrate this quickly. So that will be f multiplied t minus mu mg cosine beta dot t equals mv. And so j minus mu mg cosine beta dot t equals p. So p plus mu mg cosine beta equals j. And so we got the final answer here. So p plus mu mg cosine beta equals j. Of course, you can change this to friction. So p, momentum plus friction, should give you impulse, and that makes sense. Thanks.